compare different way to generate the Gaussian random variable. So if you use the one from MATLAB directly, it will be about like to generate 10 to the power 6, it will be 0.016354 seconds. Okay, it's not too bad. But if you try to do the inverse transformation, it's about 0.1 second. So how did you get this is use this normal inverse, because we don't have the analytic solution, but we can use computer to calculate the, give you the inverse of the error function. So it will do this, okay. And definitely this one should be slower than the, like just generate the Gaussian random number directly. And here we have another one, is the Gaussian random variable, like by the acceptance-rejection method. So you can see what we need is to have our standard uniform with our 3-dimension, and then trying to have another yi. This one is what we have here inside inside the slides is z. To generate this nature log, actually is the exponential one. Okay, and then to control the sign and to choose if we want to accept this yi or not. How to choose accept yi or not, plug the value inside to check if it's greater than or equal to this ui. And if yes, then we will let the one we want to generate to have the case. So which means for that case, we must generate like 1 over 0.76 times this sample size we want to generate. So here you can see we do is 10 to the 6. And then this is, so use 1.4 times that. This is to generate the uniform. So we have 3 different columns. And then first thing is to calculate this y. So this is the exponential one. So do the nature log. So in MATLAB, if you do log, it's just do the nature log for the first column, okay? And then keep the second column trying to check the value. So keep is equal to this is keep that or not. So trying to check if it's less than or equal to this y plus 1, that's what we have. And square divided by 2. So that's the one we want to see. And then all the yi, we just keep the one we want to have. And then we try to compute the sign. So use this sign. Okay, combine with this keep and check if it's negative 0.5 or not, or like to check the sign. Then we get this is the final answer. Then how long does it take? It's much longer than even though we do the inverse RCDF transformation. Okay, it's reasonable because we make it very complicated, and actually we generate more than we needed. It's always the case. But why we still want to learn this method, why this one is still very important, because this one gives you some other ideas how to generate this different, like random variables from different distributions. Okay. All right. Any questions regarding this one? I can show you some other simple example